Hello and welcome to G Fun Facts Online. 70% of our planet is covered by water, a vast, deep, and mysterious realm. But beneath those waves, a hidden landscape of colossal mountains and deep canyons shapes our world in ways we're only just beginning to understand. And sometimes, this hidden world unleashes forces of unimaginable power, like mega-tsunamis, waves not just tens, but hundreds of feet high. For centuries, these events were the stuff of legend and geological guesswork. But what if I told you we can now confirm these cataclysms from space? Today, we're looking at satellite altimetry, the incredible technology that lets us see the invisible and solve some of our planet's biggest mysteries. So how do you see a mountain that's miles underwater without ever leaving orbit? The answer is gravity. At its heart, a technology called satellite altimetry is a super-precise space ruler. A satellite pings the ocean with thousands of microwave pulses every second and measures how long they take to bounce back. This tells us the height of the sea surface with incredible accuracy, down to just a few centimeters. But here's the magic trick. The ocean's surface isn't perfectly flat. A huge underwater mountain, a seamount, has more mass, so it has a stronger gravitational pull. It literally pulls more water toward it, creating a permanent, gentle bulge on the sea surface above. A deep trench does the opposite, creating a slight dip. By mapping these tiny hills and valleys in the water, satellites can create a stunningly detailed map of the entire ocean floor below. It's like seeing the shape of the Earth's hidden geology by looking at the water draped over it. And this isn't just for making maps. In September 2023, this technology helped solve a major scientific whodunit. Seismic stations across the globe started picking up a very strange signal. It was a rhythmic, planet-wide tremor that repeated every 90 seconds for 9 straight days. Then it stopped, and a month later, it came back. There was no earthquake, no volcanic eruption. Scientists were stumped. What was shaking the entire planet? The clues pointed to a remote fjord in East Greenland. The leading theory was wild. As glaciers melted due to climate change, they triggered massive landslides that plunged into the fjord. One slide was so big, it was thought to have created a mega-tsunami 650 feet high, that's taller than a 60-story building. The theory was that this giant wave got trapped in the narrow fjord, sloshing back and forth like water in a giant bathtub. This sloshing, called a seiche, was rhythmically pushing on the Earth's crust, generating the mystery tremors. But it was just a theory. There were no eyewitnesses. That is, until the SWAT satellite came along. This next-generation satellite, a joint mission from NASA and the French Space Agency, could scan huge swaths of the ocean with unprecedented detail. When scientists looked at its data from the fjord during the tremors, they found the smoking gun. The elevation maps showed the water level on one side of the fjord was up to 2 meters higher than the other, and this pattern was flipping back and forth. It was the definitive signature of a seiche, the trapped mega-tsunami. For the first time, we had direct proof of these hidden monsters, confirming they were the source of the global shakes. But this technology doesn't just see the present. It helps us uncover cataclysms from the deep past. By mapping the seafloor, we can find the scars of ancient submarine landslides. The most famous is the Storega slide, off the coast of Norway, which happened thousands of years ago. Using satellite gravity data, scientists have pieced together the story of an underwater collapse so colossal, it's hard to fathom. It moved a volume of rock and sediment 200 times greater than what all the world's rivers dump into the ocean in an entire year. This triggered a monster tsunami that slammed into coastlines all across the North Atlantic, from Norway to Greenland. Satellite altimetry gave us the big picture, allowing us to see the full scale of the landslide scar and understand the immense hazard these events represent. And that brings us to the future. Understanding past events is crucial, but this technology is also becoming a vital tool for protecting us now. Landslide-generated tsunamis are a serious threat. Using other satellite techniques that can detect ground movement down to millimeters per year, scientists are now scanning coastlines to find unstable slopes before they fail. In Alaska's Prince William Sound, this method recently identified dozens of slow-moving landslides that nobody knew were there. By assessing their size and potential speed, we can get a preliminary idea of the tsunami risk they pose, flagging them for closer monitoring. It's a proactive approach to safety, made possible by our eyes in the sky. From solving live seismic mysteries and proving the existence of trapped mega-tsunamis to uncovering ancient disasters and identifying future threats, satellite altimetry has opened a new window onto our own planet. It reminds us that even in the 21st century, there are still vast, hidden parts of our world to explore, and that by looking down from space, we can better understand the powerful and dynamic forces at work right beneath our feet and beneath the waves. Thanks for tuning in to G Fun Facts Online. Join us next time for another look at the amazing science that shapes our world.